Welcome to another video. In this video, we are going to focus on evaluating logarithmic expression. For example, log 4 to the base 2. When you see a question like this, you are going to ask yourself, 2 to what power is 4? Or, how many 2's that we need to multiply to get 4? So we all know that 2 multiplied by 2 is 4. So we need to get 2 2's to have 4 because 2 squared is 4. So therefore, log 4 to the base 2 is 2. So this will be our answer. What about log 8 to the base 2? 2 to what power is 8? So we have 2 times 2 times 2 is 8. So we have 3 2's to have 8. So log 8 to the base 2 is 3. What about number 3? Log 9 to the base 3. 3 to what power is 9? So that is 2. Because 3 squared is 9. What about number 4? Log 16 to the base 4. 4 to what power is 16? So that is 2. Because 4 squared is 16. How about number 5? Log 27 to the base 3. How many 3's that we need to multiply to get 27? So that is 3 times 3 times 3 is 27. So we need to have 3 3's to have 27. So therefore, log 27 base 3 is 3. Because 3 raised to 3 is 27. What about number 6? Log 32 to the base 2. 2 to what power is 32? So we're going to have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we need to have 5 2's to get into 32. Therefore, log 32 to the base 2 is 5. Because 2 raised to 5 is 32. So this will be our answer. What about log 125 to the base 5? 5 to what power is 125? So that's 5 times 5 times 5 is 125. So therefore, log 125 to the base 5 is 3. How about this one? Log 36 to the base 6. That is 2. 6 raised to 2 is 36. Log 64 to the base 2. How many 2's do we need to multiply to get 64? So we all know that 2 raised to 5 is 36, or it is 32 rather. Therefore, 2 raised to 6 is 64. So log 64 to the base 2 is 6. What about number 10? 3 to what power is 81? So we have log 81 to the base 3. That is 3 times 3 is 9, times 3 is 27, times 3 is 81. Therefore, we need to have 4 3's to get into 81. Log 81 base 3 is 4. What about number 11? Log 49 to the base 7. So we all know that 7 squared is 49. So therefore, log 49 to the base 7 is 2. What about log 1 to the base 3? So whenever you have log 1, the answer should be 0, regardless of the base, because 3 raised to 0 is 1. Log 1 to the base 3 is 0. Therefore, our answer is 0. So let's have another example. Log 10 to the base 10. You can write this expression into log 10, because whenever we don't have a base, that is automatic 10. Now, log 10 to the base 10 is 1, because 10 raised to 1 is 10. The number 14, log 100. So we all know that 10 multiplied by 10 is 100. So therefore, we need to have 2 tens to have 100. So log 100 is 2. And then log 1000. 10 to what power is 1000? So that is 3. 10 multiplied by 10 times 10 is 1000. Now, whenever you encounter this kind of logarithm, to simplify this kind of logarithm, you just simply count the number of 0. For example, log 10, that is 1. 1 0 is 1. Log 100, that is 2. Log 1000, 1, 2, 3, that is 3. What about log 1 billion? Log 1 million is 6. 1, 2, 3, 4, 5, 6. Because 10 raised to 6 power is 1 million. What about number 17? Log 0.1. Whenever we have logarithm less than 1, the result or the answer should be negative. So in this case, log 0.1 is negative 1. All you have to do is to count the number of decimal point. So we have here 1. That is negative 1. Log 0.01, that is negative 2. So we have 2 decimal point. Then number 19, log 0.001, that is negative 3. So we have 3 decimal point. Then number 20, we have log 0.0001, that is negative 4. That is 1, 2, 3, 4. So let's have another example. Log 16 to the base 4. 4 to what power? 16. We all know that 4 multiplied by 4 is 16. Therefore, log 16 to the base 4 is 2. What about number 22? Log 1 over 16 to the base 4. Whenever we have fractional log, the result or the answer should be negative because 4 squared is 16. But 4 raised to negative 2 is 1 over 16. So therefore, the answer is negative 2. What about number 23? Log 1 over 64 to the base 4. So 4 raised to 3 is 64. But 4 raised to negative 3 is 1 over 64. So therefore, log 1 over 64 to the base 4 is negative 3. What about number 24? Log 4 to the base 64. So as you can see, the base is larger. Whenever we have base that is larger to the log, the answer should be fraction. So 4 raised to 3, that is 64. And then 4 raised to negative 3 is 1 over 64. But as you can see, our case here is 64. That will be the base. So therefore, our answer is 1/3. We are going to get the reciprocal of this one. Now, what about log 1/4 to the base 64? So as you can see, whenever we have fractional log, the result should be negative. So if log 4 to the base 64 is 1/3, therefore log 1/4 to the base 64 is negative 1/3. So this will be our answer. So let's try more example. Log 216 to the base 6. 6 to what power is 216? So we have 6 multiplied by 6 times 6 is 216. Therefore, log 216 to the base 6 is 3. What about this one? Log 1 over 216 to the base 6. So we all know that 6 raised to 3 is 216. But 6 raised to negative 3 is 1 over 216. So therefore, log 1 over 216 to the base 6 is negative 3. So this will be our answer. How about number 28? Log 1 over 36 to the base 6. 6 square is 36. 6 raised to negative 2 is 1 over 36. So therefore, log 1 over 36 to the base 6 is negative 2. What about number 29? Log 1 over 6 to the base 216. We have a fractional base. Therefore, the result is negative. And the base is larger. We're going to have the reciprocal of this one. So 6 raised to 3, that is 206. 6 raised to negative 3, 1 over 216. So therefore, log 1 over 6 to the base 216 is negative 1 over 3. What about last number? Log 6 to the base 216. So this is a whole number and the base is larger. So the result is fraction. So 1/3.